Alright, we've come a long way. Let's bring it all home. We started with a question. What's actually happening when you type something into ChatGPT or Claude and get a response? And now you know. You know that it starts with a staggering amount of text, trillions of tokens scraped from the internet. You know that the model breaks that text into tokens and plays a simple game billions of times. Predict the next word, check, adjust. You know that the model itself is a giant mathematical function, billions of dials carefully tuned by gradient descent. You know what happens inside. Embeddings give words meaning as numbers. Attention lets words talk to each other. Feed-forward layers refine that understanding. And this repeats across 100 layers before the model picks its next word. And you know that after all of that pre-training, the raw prediction engine gets shaped into an assistant through fine-tuning and reinforcement learning. That's the full pipeline, and none of it is magic. So let me leave you with 3 things that I think are worth keeping in mind every time you use these tools. First, it's not magic. It's a mathematical function with billions of tuned parameters. There's no ghost in the machine, no secret intelligence hiding in there. It's numbers multiplied and added together in very clever ways at enormous scale. That doesn't make it less impressive. It makes it more impressive. Because it means human beings built this. We understand the pieces and we can make them better. Second, it's not thinking. Not the way you and I think. It's pattern matching at extraordinary scale. It has no inner experience. It doesn't understand your question and then decide on an answer. It processes your input through its layers and produces the statistically most likely continuation. The result looks like thinking, it feels like thinking, but the mechanism underneath is fundamentally different, and knowing that helps you stay clear-eyed about what it can and can't do. Third, it's not remembering. It's reconstructing from compressed patterns. When it tells you that Paris is the capital of France, it's not pulling that from a database. It's reconstructing it from the patterns encoded in its parameters. The same way you might remember a movie plot from years ago. Mostly right, but sometimes off. This is why it hallucinates. And knowing why it hallucinates is the single most useful thing for using it well, because now you know when to trust it and when to double check. I genuinely believe that understanding how these models work, even at this intuitive level, changes how you interact with them. You start prompting better because you understand that more tokens means more thinking time. You stop asking for one-word answers to hard questions. You start saying, think step by step. You give the model more context because you know that attention can only work with what you give it. You trust the output more appropriately. You stop treating it like the ultimate truth. You understand that it's very likely to be right on common, well-represented topics and more likely to drift on rare, niche or very recent information. So you verify when it matters. And you see through the hype. When someone tells you AI is thinking or understanding or conscious, you know what's actually under the hood. And when someone tells you it's just autocomplete and dismisses it, you also know that's not the full picture. You can hold both truths. It's simpler than people think, and it's more capable than the simplicity would suggest. One last thing, everything I've described is the foundation and it's moving fast. Context windows, the amount of text the model can look at when making a prediction, are growing rapidly. Models that could only see a few thousand words a couple of years ago can now see hundreds of thousands of words. That means they can read an entire codebase, an entire legal contract, an entire book, and reason about all of it at once. Reasoning is getting dramatically better. Reinforcement learning is teaching models to think longer, try harder, and develop more sophisticated problem-solving strategies. The gap between last year's models and this year's models in complex reasoning is massive, and that trend is accelerating. Models are learning to use tools, browse the web, write and run code, search databases, call APIs. They're not just predicting text anymore, they're taking actions. And multimodality, models that can see images, hear audio, and generate both, is becoming standard. The text-only world we talked about in this video is already expanding into something broader. The fundamentals we covered today aren't going away. Transformers, attention, next word prediction, gradient descent, that's the foundation everything is being built on. But what's being built on top of it is changing month by month. And now that you understand the foundation, you're in a much better position to follow along, to adapt, and to make the most of these tools as they continue to get better. I hope this was useful. If it clicked for you, share it with someone who's been curious about how this stuff actually works. And if you want to go deeper, I'd highly recommend watching the full 3 Blue 1 Brown series on neural networks and the Andrej Karpathy talks. I've linked both in the description. Please do like this video, subscribe the channel for more such quality content, and please tell me in the comments how was your experience learning how LLMs work. Thanks a lot for watching. I will see you in the next one.